What happens if nanobots cannot be removed? Imagine tiny robots so small they are invisible to the naked, working inside your body to fight disease or repair tissues. These are nanobots, and they hold incredible promise for medicine. But what if, after their job is done, they can't be taken out? That's a question that sparks a lot of curiosity. Nanobots are designed to be extremely tiny, often less than 100 nanometers in size. That means they are 1,000 times smaller than the width of a human hair. They can target specific cells, deliver medicine directly where it's needed, and even repair damaged tissues. But once inside the body, their small size makes removal a real challenge. And like a surgical implant, nanobots are too tiny for current medical tools to grab and extract easily. If nanobots cannot be removed, several issues could happen. First, the immune system might see them as invaders and attack. This could cause inflammation or swelling, which might damage nearby tissues. Some nanobots are made from metals or other materials that could corrode over time. When they break down, they might release toxic substances into the body, leading to potential poisoning or tissue damage. For example, metallic nanomaterials can corrode in the oxygen-rich environment of the body, which might cause inflammation or even damage to surrounding tissues. Another concern is that nanobots could interfere with normal cell functions if they stay inside the body for too long. They might physically block blood flow or disrupt how organs work. If they gather in organs like the liver or kidneys, they could cause blockages or damage. Some nanoparticles, similar to nanobots, have been shown to cause DNA damage or oxidative stress in cells, which could lead to cellular toxicity if nanobots remain unchecked. Powering and controlling nanobots is another tricky part. If they lose energy or malfunction, they might become inert debris or behave unpredictably. Since they are so tiny, current technology makes it nearly impossible to retrieve them once they are inside the body. This could lead to unexpected biological effects, some of which might be harmful or cause strange anomalies at the microscopic level. From a bizarre biology perspective, if nanobots are left inside, they might multiply or cluster together, forming strange structures. They could interact with cells in unpredictable ways, leading to unusual biological anomalies. For example, nanobots could accidentally trigger immune responses or even from tiny colonies that behave like foreign organisms. This highlights the importance of designing nanobots that are biodegradable or can be safely deactivated. Researchers are working on making nanobots that can break down naturally after their work is done. These biodegradable nanobots disintegrate into harmless substances, reducing the risk of long-term problems. Some coatings and materials are also being developed to help nanobots blend with natural tissues, making them less likely to cause immune reactions. But until these solutions are perfected, the inability to remove nanobots could pose health risks like inflammation, toxicity, or interference with normal body functions. In the end, if nanobots cannot be taken out, they could cause immune responses, tissue damage, or cellular toxicity. Their tiny size makes removal difficult with current tools. That's why designing nanobots to safely degrade or be controlled remotely is a key focus in this field. It's all about making sure these microscopic marvels help us without creating new problems down the line.